Our electrical grid, it's a beast, right? One of the most complex machines ever built. But here's the thing. It's kind of running on old school tech while facing some very 21st century problems. So the solution isn't just about making it bigger, it's about making it smarter. Let's get into it. Okay, so every single day, our grid basically goes through this massive stress test. Just look at this graph. You see those two huge spikes? That's what we call peak demand. It's that morning rush when everyone's firing up coffee makers and hair dryers, and then it happens all over again in the evening when we get home. Trying to meet that surge day in and day out, well, that's one of the biggest headaches for our entire energy system. So that leads us to the big question, right? How do we build a grid that can actually handle all this without just building more and more power plants that only run for a few hours a day? How do we make it smarter, not just bigger? Well, the first thing to get is that the smart in Smart Grid isn't about some single magical piece of tech. Nope. It's all about a foundational set of rules. Think of it like a rulebook that lets thousands of different gadgets and systems all work together without crashing into each other. And this is really the key takeaway. We don't have to pick one winner, like is solar better than wind, or is this battery better than that one? Instead, what we really need are these universal standards. That way, any new technology can just plug and play, safely and seamlessly. So this slide breaks down two of the most critical rules coming out of research from the National Renewable Energy Laboratory. First up, you've got interconnection. That's IEEE 1547. The easiest way to think about this is a universal plug. It's the set of rules that lets a new set of solar panels or your EV charger physically and safely connect to the grid. Simple enough. But then you've got interoperability, or IEEE 2030. This is the common language. This is what lets all those different things talk to each other and coordinate their actions. So one lets you plug in, the other lets you have a conversation. You absolutely need both. And boom, this is what you get. Our grid isn't a one-way street from a big power plant to your house anymore. It's this incredibly complex, dynamic system of systems. You've got energy flowing in every direction, from giant power plants, sure, but also from local wind turbines, rooftop solar, and even home batteries. Honestly, without that rulebook we just talked about, this would be total chaos. These standards are literally what keep the lights on. Okay, so we've talked about the rules in the abstract. Now let's see what they actually build. Let's look at a really powerful, real-world example they make possible. Something called a microgrid. A microgrid is, well, it's pretty much what it sounds like. It's a mini version of the main power grid, maybe for a campus, a hospital, or even just a neighborhood. It can generate its own power locally, but here's the killer feature. It can operate independently. It can island itself if the main grid goes down. That makes the local power supply incredibly reliable and resilient. Sounds great in theory, right? But how much of a difference can one of these things actually make? What do the numbers say? Well, lucky for us, a simulation study put this exact question to the test. To figure this out, researchers modeled a microgrid and ran a 24-hour simulation. They compared 3 different setups to see which one really came out on top. And here are the 3 scenarios they tested. Case A is our baseline, the old school way, where the main grid just supplies all the power. Case B steps it up a notch by adding solar panels, or PV. And then Case C, that's the full-on smart microgrid. It's got the solar panels plus a battery energy storage system, or BESS for short. All right, first up, what happens when you just add solar panels? This graph shows the demand on the main grid. The blue line is our baseline, and the red line is with solar. See that huge dip in the red line right in the middle of the day? Awesome. The solar panels are doing their job, carrying the load. But then, look at the evening peak. It's pretty much the same as before. And why? Well, it's obvious, right? The sun's gone down. So solar helps for sure, but it doesn't solve that big evening problem. And that is where Case C comes in and just changes the whole game. This little flow chart shows the brilliant, simple logic. During the day, when the sun is blazing and the solar panels are making more power than the building needs, the system is smart enough to say, hey, let's not waste this, and it uses that extra juice to charge up the battery. Then, later, when that evening peak demand hits and the main grid is groaning under the strain, the system just flips a switch and uses the power it saved up in the battery. It's genius. This really simple strategy, just storing that daytime solar power for later, it has an absolutely massive impact. So let's get to the big reveal, the final results. So, the key question, how much did this smart battery system cut down that peak load, that single moment of maximum strain on the grid? The number is 32.7%. Almost a third of the stress just gone. And here's the quote straight from the research paper that puts that number into perspective. Not only did it crush that peak demand, but the smart microgrid used less than half the total power from the main grid over the entire day. That is a huge, huge leap toward local energy independence. This table just lays it all out, plain and simple. Look at that top row. Peak load reduction jumps from a decent 12.7% with just solar to that incredible 32.7% when you add the battery. But for me, the next row is even more telling. PV utilization. Without a battery, you're basically throwing away over a third of the free energy from the sun. With a battery, you use 92% of it. You're capturing almost everything. The difference is just staggering. So let's zoom back out and bring this all home. The future of our grid, it's not just about building bigger, longer power lines. It's about building a smarter, more decentralized network, a system of systems made up of all these intelligent little microgrids, all speaking the same language, and all working together to give us a more resilient, efficient, and cleaner energy future. And this really leaves us with a powerful final thought. We've seen the rules that make it possible, and we've seen the incredible results from just one of these microgrids. Now, just imagine that at scale. What really happens when your entire community can generate and store all the power it needs? It's more than just a smart grid at that point. It starts to look like a full-blown revolution in how we think about energy.